Hi friends, welcome back to your channel. That is on JEE Physics. So this is JEE Advanced 2026, Paper 1, Physics Solutions. We have been continuing the journey. So this is question number 3. It was relatively an easier question. The idea remains same. Whenever you are solving these questions, pause the screen. First try to do on your own. If you get stuck, then only refer to the solution. Otherwise, do not look at the solution. Now let us read the question. A solid cylinder of radius r rolls without slipping, very significant. So they are talking about pure rolling over here. With the center of mass P V naught equal to this on a horizontal surface with a vertical edge. Here G is the acceleration due to gravity at the moment when the cylinder loses contact with the surface due to rotation around the corner. This is very significant here. Very significant. What do you mean by this particular statement is that there is no slipping. There is no slipping of the edge. There is no slipping of the edge. This is very significant. There should not be any slipping of the edge, because if the edge slips, then we will not be able to apply the energy conservation. There will be a problem. So now you can check this out by conserving the angular momentum also. Initially, angular momentum L initial will be equal to R cross P center of mass plus I center of mass into omega, since it is in pure rolling, and L final when it is basically moving over this particular edge. So their moment of inertia about this particular corner P, point P, into omega. And by doing Li is equal to Lf, you will get a clear-cut idea that there is no loss in energy itself. So now let us come to the problem. It was considered to be an easy problem. It was easily doable. Any good student with decent amount of preparation could have done this question very easily. So here, let us say that it was traveling up to that, and from this particular edge, from this edge, it is now falling. So I'll take a diagram here. Yeah, so I'm assuming it is falling like this from the edge. Okay, all right. So here, this is the line of linear velocity. This is the line of linear velocity. So I'll assume that this is the center. Here we have the center. This point is referring to the center, correct? And here, if we say that it is somewhere around here, this angle is theta. So now initial kinetic energy initial will be equal to half mv square into 1 plus c. That is the equation that we use to express the total energy, kinetic energy in case of pure rolling. So it is coming half mv square into, since it is solid cylinder, this is half. So this becomes 3 by 4 of mv naught square, mv naught square. Now let us talk about the final energy. So what about the final energy? Final energy, here this central line I am assuming to be a reference line. That is also a very important thing. Please do remember, this line I am considering to be reference line to calculate the potential energy. So I am assuming the initial potential energy to be equal to 0. So when it is finally moving about this particular point, Pkf will be equal to half Ip into omega square. So that will become half I about point P will again become 3 by 2 mr square by applying the parallel axis theorem into omega square. So this becomes 3 by 4 m omega square r square. Omega r is a velocity at that particular point, so it is 3 by 4 m v square. Now talking about the potential energy at this UF, since this is the reference line, so it has come down by r cos theta, so we can write mgr into 1 minus cos theta. This is again very easy to calculate. I hope all of you remember this calculation. So if I take this as to be r, then this angle is theta. So this particular portion becomes r cos theta. This is my reference line. So if this is the h will become r minus r cos theta. Hence it becomes r into 1 minus cos theta. So now simply apply the energy conservation. So I can write 3 by 4 mv naught square is equal to 3 by 4 mv square minus, why minus? Because it is below the reference line. That is why mgr into 1 minus cos theta. So this is my equation number 1. Let us say this is my equation number 1, right? Fair enough. Next, since it is losing contact, so in losing contact, what will happen? Their normal reaction at this particular point will become 0. So if you just go back to the diagram, you will see okay, this is the cylinder. We are seeing the cross-sectional view. So here, this will be mg, and this is the angle theta. So this will be mg cos theta. And here in this direction, we are supposed to get the normal reaction, but we are not getting. So directly we can write mg cos theta is supplying the necessary centripetal force, that is equal to mv square by r. So from here we get v square is equal to gr cos theta. This is my equation number 2. So I'm assuming this is my equation number 2. So now, if I replace this, if I replace the value of this one in the previous equation, we'll get the solution immediately. Let's do it. Yeah. So now the values are coming to be, we can write 3 by 4 mv naught square is equal to 3 by 4 mv square minus mgr into 1 minus cos theta. I will eliminate m from all sides. So 3 by 4 v naught square is equal to 3 by 4 m. Sorry, we have eliminated m already. So v square means gr cos theta minus this is coming gr plus this is gr cos theta. So what I do here, 3 by 4. V naught value is already mentioned here, that is to be under root of gr by 3. So v naught square becomes gr by 3. This cancels out. That is equal to 3 by 4 gr cos theta plus gr cos theta makes it 7 by 4 gr cos theta minus of gr. Bring this gr on the left side, so it becomes gr by 4 plus gr is equal to 7 gr cos theta by 4. So 5 gr by 4 is equal to 7 gr cos theta by 4. Gr cancel, 4 cancel. Cos theta value we get 5 by 7. So once we get cos theta 5 by 7, then from equation number 2, we get v is equal to under root of 5 gr by 7. So that should be the answer to this question. I hope you have enjoyed this solution. If you have enjoyed, then please do like, share and subscribe. Thank you. See you in the next video.